In this video, we will show how to work with a continuous cumulative distribution function, defining it, assuming it's not a built-in function, and using it to calculate probabilities, and using it to find the probability density function for the appropriate random variable. We're going to do this in R, and then we will show how we could fill in answers in a WebAssign assignment. So here's the problem. The cumulative distribution function is 3x plus x squared divided by 18. This will be defined between 0 and 3. First question is create a user-defined function for f in the interval 0 to 3. The easiest way to do this in R, here's the R console, is to first create an R document or script. Kind of easy to do. Just file and new document. This is the Mac version. In the Windows version, it'll be file and new script. Let me just bring this in here. And user-defined function, name of the function, which in this case is f. Assign the word function, the argument. I'll put a brace in here, and then it's 3 times x plus x squared divided by 18. Press enter. And if I run this in R, I just see my command, but the function's actually been defined. If I type f of 3, press enter, I get 1, which I should get because this function, the cumulative distribution function, will be 1 at the maximum point, which is 3. Actually, it's 3 and anything above, but this really is only defined between 0 and 3. If I typed f of 0, I hope I'll get 0. And lo and behold, I do. Now, if you look, the next thing is I said, using this function, find the probability that x is less than 2. Well, with the cumulative distribution function, this is just be the function evaluated at the point for a less than. I can run this if I want. And lo and behold, I get 0.5555. The next, find the probability that the random variable is between 1 and 2.5. No problem again. For cumulative distribution function, evaluate at the right-hand endpoint, which is 2.5, minus evaluated at the left-hand side, which is 1. I can execute this, and I get 0.5417. You'll notice the script is really just in a text editor. It's not actually part of R itself. So I can save this and then bring it back and basically solve the same or similar problem again without re-inputting values. The next one, use f, find the probability x is greater than 2. Now, the probability that x is greater than 2 is 1 minus the probability x is less than or equal to 2. Which is kind of easy. 1 minus f of 2. Because this is a continuous distribution function, the probability of being less than or equal to 2 is the same as the probability of being less than 2. I can now evaluate this, and I get 0.4444 in this case. Now, the last question we have is, what's the probability density function for x between 0 and 3? Now, it winds up that for any cumulative distribution function, its derivative is the density function. So we have to find the derivative of 3x plus x squared divided by 18. And there are two ways to do it. This is a pretty simple function. The derivative is going to be 3 plus 2x divided by 18. I could put this in, but I'm going to put a number sign here. Because I want this to be a comment. I basically did this in my head. I'm not going to define this as a built-in function in R, but just going to show the formula for the density function. There's actually another way I could have done this. And that is to use a built-in function called capital D. R usually does not do symbolic work, but it actually can work with simple derivatives. And this particular command, well, actually, let's see what you get when you actually execute it. Lo and behold, there's 3 plus 2 times x divided by 18. And basically, that's this particular question. For those people who want to put in comments for any line, you can put a number sign, and anything after the number sign is a comment for R, which R will not execute when you execute that line, but it's really for the user. Most good programmers will comment almost everything. Now, our script can actually be run kind of easily. Let me first erase the screen. I'm clearing the console, and I'm going to just run the entire script. There it is. Now, what I actually want you to do in all of these is, before the first line of your script, a comment. That's so I really know whose script this is. Number sign, and then your name. So if I clear the screen again, and I execute this whole thing now, this is what this looks like. Okay, now the next thing I want to do is actually answer the questions in WebAssign. So let me actually just copy this, makes it easy. Notice my computer almost tilted here. Okay, so let me bring over WebAssign. And here's basically how the question looks in WebAssign. So my user-defined function, kind of easy. You basically put in the command you had. It's much easier to copy and paste, which I think I will do now. I have to get this out of the way. Just paste it in there. All of the non-numeric questions like this are going to have to be graded manually. R is very sensitive to things like extra spaces or whatnot. So if you have a valid function definition for f, it would be marked correctly. Now, the answers, probably x is less than 2. I think it's 0.5555. Between 1 and 2.5, I think I got between 5,417. Greater than 2, I think I got 0.4444. By the way, I told you to do these to 4 digits of accuracy. I'm actually checking up to 3. I usually put 4 in anyway. And the probability density function is 3 plus 2 times x divided by 18. Once again, this will have to do, for now, I would have to manually grade this particular answer. Now, for the R script, this is very important. Either you could take the script that you've written, like this, and paste it in. By the way, for longer scripts, this box does expand or subtract or get smaller. Another way you might want to do this, let me just get it out, is to get the code as after it's run. Let me just run this again. And paste it in. I really prefer the first method because I can just copy and run the code to see if it's accurate. And then we submit the answer. And what you should see are the green checks by the numerical results. And these non-numerical results, I'm going to have to grade manually. And basically, that is how you can handle the questions on your R work. And that's the end of the video.